Chapter 3. Saturn's Rings Explained. Luminous sources at Saturn have been observed, notably by Herschel, Knight, and Ainsley. In one instance, a fiery source moves suddenly away from the A-ring outer edge. In another unrelated instance, a bright, elongated source pursuing a straight line course entered the A-ring outer edge, traversed the Cassini division, and exited the opposite A-ring outer edge. After these dramatic events, luminous sources did not become a specific subject of inquiry as might be expected. That is, until this analysis many years later. A number of luminous sources appear in Voyager imagery. One of these sources, located in the A-ring, is documented in the photograph of Plate 3. A pointer locates this source, which appears as a small reddish-orange spot. In the picture, the A and B rings readily can be identified, and even some of the faint C ring can be distinguished. The Cassini division, pointed to in the upper left corner of the picture, clearly is formed by a separation between the A and B rings. Diagonally, in the opposite corner below the luminous source, a comparably formed Cassini division is absent. The B ring outer edge is complete. However, between points 1 and 2, the A-ring is nowhere to be seen. A segment of the A-ring appears strangely terminated across a chord of the entire ring system. Absence of this ring segment is addressed subsequently. Because of the shallow view angle of Saturn's rings in Plate 3, the distance between points 1 and 2 appears very highly compressed. As a result, the immense length of the ring segment chord is not readily comprehensible. To aid comprehension, Plate 4 conceptualizes the incomplete A-ring in a polar view of Saturn's northern hemisphere. Earth profiles are introduced to provide a familiar reference measure. Line of sight is perpendicular to the ring plane so that all rings appear in true relative proportion. The length of the ring segment chord is greater than Saturn's diameter. This fact is illustrated by projection of parallel dotted lines from Saturn to the chord. These dotted lines intersect the ring chord within the cutoff segment of the A-ring, the Encke division. Placed at 2/5 the A-ring width from the outer edge can be seen to intersect the chord at nearly the same points as the projected dotted lines. The distance subtended by the entire chord is equivalent to slightly over 10 Earth diameters. Only about 6 Earth diameters comprise the radial distance from Saturn's surface to the A-ring outer edge. Other distances also can be compared. For example, the radial span from the inner edge of the A-ring to the outer edge of the Encke division is about 1 Earth diameter. Span of the Encke division is expressed by a mere line width inasmuch as this gap is only about 200 kilometers, 125 miles across. Radial span of the Cassini division is about 0.3 Earth diameter. As before, Saturn's diameter is 120,660 kilometers, 74,980 miles. Circled numerals cross-reference the corresponding numerals shown in Plate 3. When the photograph of Plate 3 is enlarged in the vicinity of numeral 1, the information of Plate 5 is obtained. In plate 5, efflux from along the length of a slender body exhausting at both ends generates the A-ring. The luminous source seen near numeral 2 in plate 3 appears at the left edge. Inspection of plate 5 indicates that a slender body is orbiting clockwise and, in doing so, deposits a wide trail. This trail, which can be recognized as the A-ring without the NK division, is generated by efflux emanating from nearly the entire length of the body. While most of the efflux is generated along the top, some also appears to begin underneath and along the body sides in the form of streamers. These streamers pass over the side toward the right, proceed above the body, and contribute to the A-ring trail. Presence of exhaust flames from each end of the body and the bulgy appearance of the streamers as they pass over the body suggest a circular cross-section for the body. A light source, somewhat greater in diameter than the body, is positioned below the right end. This source is attached to the body, with interconnecting emissions turning to an orange-red arc along the top edge. Emissions from the body can be viewed collectively as creating a net force on the unit. According to one of Isaac Newton's laws of motion, forces can occur only in action-reaction pairs. The reaction of the body to the action of the emissions is to move the body, presumably in a direction so as to complete the ring. This physically inherent mobile capability is justification for calling the body a vehicle. The ratio of apparent body length to thickness, called apparent fineness ratio, is about 13:1. Absolute dimensions corresponding to finesse ratio 13 can be estimated. Consider that the vehicle lies along the chord identified by numeral 1 in plate 4, and that the vehicle extends from the A-ring inner edge to the NK division inner edge. By scaling the illustration in plate 4, the body length is found to be about 0.3 Saturn diameter, or about 36,200 kilometers, 22,500 mi. This length corresponds to about 3 Earth diameters. Based on a 13:1 finesse ratio, the body diameter can be deduced to be 2,785 kilometers, 1,730 mi. This distance is about the same as the airline distance from San Francisco, California, to Louis, Missouri on the Mississippi River. Such an immense propulsive body implies a space engine possessing unheard of capacity and capability. When the photograph of plate 3 is enlarged in the vicinity of numeral 2, the information of plate 6 is obtained. In plate 6, a second slender vehicle forms an A-ring trail, which includes a luminous source. This source is the same one identified in plates 3 and 5. Breadth of the source is estimated to be about half the distance between the A-ring inner edge and the NK division inner edge. This sizing places the breadth of the luminous source at about 5,600 kilometers, 3,480 mi. This distance is slightly over 1.5 times the diameter of Earth's moon and about the same as the airline distance between New York and London. The large magnitude attests to the vast energy powering the engine of the slender space vehicle. Projecting from beneath the luminous source in plate 6 is a wire-like arm which curves upward into the foreground toward the left. At about 1/3 of its length from the bottom, the arm has a bulge in it. This bulge appears to be a donut-shaped formation, or a toroid through which the arm passes. Presence of a toroid indicates that the arm is acting as a conductor carrying electricity. Such as indication is given because physically a circular conductor of electricity has, in cross-section, magnetic field lines consisting of concentric circles, i.e., circles with a common center. Magnetizable matter caught in such a field will align itself concentrically with the conductor and collectively assume a toroidal shape. Diameter of the conductor is in the neighborhood of 350 kilometers, 220 mi. Length is of the order of 4,000 kilometers, 2,500 mi. Without this arm, maintenance of the luminous source probably would be impossible. Scaling the vehicle in plate 6 yields an apparent finesse ratio of about 13:1, the same as for its companion vehicle in plate 5. Orientation of the trails from both vehicles suggest that the two are moving toward one another, apparently on a collision course. A collision would not occur, of course, were the vehicles in different planes, or were one to surrender its position to the other. Preference is for the latter. Excluding bulb luminous sources, plates 5 and 6 tend to show that vehicle diameter is an approximate measure of thickness of the A-ring at inception. For the time frame shown then, maximum ring thickness inferentially would be of the order of 2,785 kilometers, 1,730 mi. Obviously, at large distances from the vehicle, at the ring edges and for old trails, the ring would be expected to be much thinner and more diffuse. Plates 3, 5 and 6 confirm the early observations of moving luminous sources by Herschel, Knight and Ainslie. Herschel is credited with a source of variable luminosity, possibly of a fiery character. Knight and Ainslie reported a luminous source as bright as a star. Both descriptions fit acceptably well that which is discerned from the 3 plates. An additional commonality exists between the Knight-Ainslie event and the 2 vehicles in plates 5 and 6. Specifically, the chordal path of the Knight-Ainslie moving source is the same chordal element defined by the location and orientation of the 2 vehicles. Whether these chords are in the same approximate position around the ring is beyond the scope of this inquiry. Plates 5 and 6 reveal that width of the Cassini division occurs neither accidentally nor with exact repeatability. The reason is that the basic spacing depends upon the radius at which a mobile vehicle orbits with respect to the B ring. Even though this orbital radius might be constant, a substantial degree of variability in character of the trailing flux can alter the radial location of the inner edge of the A ring. Also, the extent of flux emission along the length of a vehicle can influence the width of the Cassini division. These possibilities for differences explain the variability in measurements by different observers over the years. Fairly narrow tolerances, astronomically speaking, on the radius of the B ring outer edge and the A ring inner edge have led observers to conclude that the Cassini division is a true gap. That the NK division is a true gap has been doubted because of its apparent absence from time to time. Actually, the NK division is formed in the same manner as the Cassini division, and in this sense, the Encke gap is just as true as the Cassini gap. Plate 7 shows formation of the Encke division. In the plate, the A and B rings as well as the Cassini division can be recognized. Once again, a vehicle is found depositing an orbital trail. Efflux emanating primarily from the radially outboard, 2/3 of body length is responsible. Clearly, were the vehicle located at a slightly shorter radius, the gap would be lessened. Widths reported for the Encke division range from approximately 200 to 320 kilometers, 125 to 200 mi. Nominally, this gap width is equivalent to a variation in orbital radius of only about 1/4 of 1%. The implication is that orbital radius of vehicle position is set very precisely in order to have a gap produced. Inspection of the vehicle reveals numerous jets issuing from many different positions around and along the body. A fan of 3 jets appears to form the inboard part of the trailing efflux. Each jet appears to consist of a series of bulbous swellings. Such swellings are indicative of the form of electrically charged flows known as pinched plasmas. Length of the vehicle appears to be about 10 times in diameter. A dark jet crossing the body near the left end makes the vehicle appear as though there are 2 sections aligned longitudinally. In reality, the vehicle is integrally one. An attempt at sizing yields an apparent length of about 4,700 kilometers, 2,900 mi, and a diameter of 470 kilometers, 290 mi. Diameters of issuing jets are of the order of 0.1 to 0.2 body diameter, or about 47 to 94 kilometers, 29 to 58 mi. Numerous photographs have been examined with special attention being given to the outermost region of Saturn's A-ring. The search produced another vehicle at the outer edge of the Encke gap. This second vehicle, shown in plate 8, substantiates the process by which the outer A-ring and the Encke division are formed. In the plate, the Cassini division, the entire breadth of the A-ring and the Encke division can be discerned. The outer annulus of the A-ring, defined by the Encke division and the A-ring outer edge, again is found to consist of a trail deposited by a slender vehicle. As before, efflux emitted from around and along the body is the source of the trail. Were the same profuse efflux to occur completely along the vehicle length, little separation would prevail between the new trail and the older inner A-ring deposits. Geometry of the trail and vehicle radial location produces an Encke division whose centerline is located inboard from the A-ring outer edge, about 1/5 the A-ring width. Apparent finesse ratio of the vehicle is 13:1 as compared with 10:1 for the vehicle of plate 7. Sizing yields a length of about 2,500 kilometers, 3,200 mi, and a diameter of 400 kilometers, 250 mi. While the 2 vehicles roughly are comparable in magnitude and quite similar in certain respects, they also have differences. A notable difference is that the instant vehicle seems to have a longitudinal exhaust, whereas the previous one very definitely does not. Differences in length and longitudinal body flux distribution lead to a difference in width of the Encke division. For the shorter vehicle, Encke division width is about 1% of the distance between the A-ring inner and outer edges. For the longer vehicle, the Encke gap width is about 6% of A-ring width. Nominal values reported are in the range of 0.5 to 2%. A conclusion is reached that the A-ring outer annulus can be constructed with vehicles having different lengths and emission patterns. Therefore, the Encke gap can be located almost anywhere or not at all. Within the A-ring, depending upon length and positioning of the vehicles forming the inner and outer annuli, in view of this possibility, the difficulty of early observers is pinpointing a single radial location for the Encke division is now readily understandable. Inability to obtain unanimous opinion for ring thickness is also explained. Formation of the Cassini division might be expected to follow a development pattern similar to the Encke division. Specifically, a vehicle should exist which spaces the B-ring inboard of the A-ring inner edge so as to form the Cassini division. This expectation is realistic can be shown by plate 9. In this plate, a partially developed ring system is shown exhibiting a cylindrical vehicle positioned across the B-ring. An apparent included angle of about 30 degrees is formed by two imaginary lines having a point of intersection on the ring's outer edge. One line is the vehicle longitudinal axis and the other a line perpendicular to the outer ring edge, i.e. radial line. At the point of intersection, body angularity less than 90 degrees with respect to the radial direction indicates that the vehicle occupies a slewed position within the ring. A slewed position is consistent with that observed for vehicles located in the inner and outer A-ring annuli. In plate 9, ends of the B-ring vehicle are labelled. At the left end, a short length of axial exhaust is detectable. An implication is that condensed and solidified exhaust products are the primary constituents of the C-ring. At the right end, the axial exhaust stream can be identified passing through the A-ring. Penetration of the stream through the A-ring vaporizes in-path material and renders the ring discontinuous. Also, at the left end, 3 bulbous jets of matter are ejected. Towards the right end, 3 more bulbous jets emerge from a small common area. Quite likely, all the bulbous jets are pinched plasma formations, inasmuch as the presence of substantial heat in exhaust products is indicated. Emissions at other body locations are identified in the plate. All the ejected matter, except for the right end bulbous jets, provides intimate substance and texture to the B-ring. The right end jets rise above the vehicle, form an arch, and connect with the A-ring. Apparent finesse ratio of the body is in the neighborhood of 13:1. Rough sizing places vehicle length at about 29,500 kilometers, 18,300 mi, and a diameter at 2,250 kilometers, 1,400 mi. That vehicles do not confine themselves only to positions in the A and B rings is illustrated by plate 10. Shown in the plate outside the A-ring is an emitting slender body positioned near the F-ring location. Axial exhaust appears to emanate from the body ends, locations of which are identified. Issuing from topside at the right end of the vehicle is a long streamer which extends leftward towards the A-ring. This long streamer and the axial emissions are primary contributors to a massive cloud which forms in the vicinity of the vehicle. Secondary contributors are jets discharging laterally, not labeled. Highest cloud density occurs below the A-ring near the right edge of the photograph. This occurrence suggests a long axial exhaust emission which, owing to very elevated temperature, requires a considerable distance before the constituents reach the cloud-forming condensation point. Lowest cloud density occurs below the body, attesting to the comparative minor nature of lateral and downward emissions. Intermediate cloud density is displayed between the trailing streamer and the A-ring. In the vacuum of space, where the environmental pressure is practically zero, a crossflow can occur only because of an electrical pressure difference between 2 points. An electrical pressure differential causes electricity or electrons to flow from the higher pressure to the lower one. These flowing electrons necessarily must come from a highly ionized volume of matter, an obvious source of which is the vehicle. This situation again points to the reasonable presence of pinch plasma formations. Overall, cloud breadth is estimated to be of the order of 3 Earth diameters. Apparent finesse ratio of the vehicle is about 12:1. In summary, the A and B rings are formed by slender mobile vehicles trailing massive efflux. The Cassini division and the NK gap within the A-ring are created simply by definite radial spacing of the respective formative bodies. The C-ring and the F-ring formations apparently depend upon the presence of a nearby vehicle. At birth, the A and B rings appear to have electromagnetic properties. In view of the generating mechanism, heretofore confusing variations in observational results now become explicable.